Hello, everyone. My name is Carola Nitz, and today I'm going to talk about debugging, things your senior hasn't told you about yet. So this is a very important topic for me. In order to fix problems, you need to understand them fully. And this is like building a house. When the foundation is not great, you can't just try building on top of it and try to fix it. So let's take a look at how much time we actually spent debugging and making things work. So this is a study from the Cambridge University. It turns out we're spending 50% of our time with making things work or debugging. This is a lot. It turns out it's $312 billion spent per year for the entire global software industry. So why is that actually? What problems do we face? So first one is sometimes we simply don't have enough information. In this case, I tried to debug a problem that I had, and I landed somewhere in UIKit, and I couldn't figure out what part of my code actually was causing this. And I'm going to show you how you can get more information when you're stuck somewhere in Apple's frameworks. Then the second, we sometimes have a lot of time-consuming tasks. Like in this case, I tried to cast an address to UIView and print the frame, but it told me, yeah, I cannot find the property frame on this object, and I needed to import UIKit to make it work. So I'm going to talk a little bit about handy breakpoints and arguments that help you find the source of the problem. And last but not least, there we go. Sometimes we don't know about good practices or some tools that we can use. So I'm going to tell you a little bit about defensive programming practices that will catch code issues when they occur, and a little bit about asserts and precondition. So first up, getting more information. Earlier this year, I was working on the Apple TV app for VLC, and I was stuck in an unresponsive UI. Like nothing would scroll, and I couldn't click anywhere, and images wouldn't load. And when I stopped the project, I saw that I had high memory pressure. So this is obviously the first indicator that we're somewhere in an infinite loop. So I took a look at the stack trace, and what I saw was that it was somewhere stuck in UIKit. There was nothing I could do. I couldn't even like Google and use Stack Overflow, so here's what I did. I was a little bit, sad. But after doing that for a while, I remembered there's actually this one command in LLDB, so LLDB to the rescue, and that is called register read. Register read shows you the general purpose registers. These are used for transient data. And I'm not sure if everybody can see that, but there in register 10, I had a reference to the VLC networking image view. This was enough for me to then go into the code and brute force and comment out some lines to then find the line that actually was causing this issue. So I was a happy developer. I found out how to make this work. And then a month later, I learned, I could have had it easier. Tyler Fox was tweeting about a not widely known, underappreciated debugging tool in UIKit and AppKit, which helps you to find the reason for hangs or crashes that are caused by an infinite layout loop. And this is a feedback loop debugger, which is a launch argument. And before I go into details, I'd like to tell you a little bit about launch arguments. So you can set launch arguments when you edit your scheme, and it's in the second tab. And here you can see I set the UIView layout feedback loop debugger threshold, but you can also set their environment variables. Apple has been so nice to give us already some of them in the options tab here, the launch arguments that is. You can, for example, change your application language. So if you want to see how your app looks in German and want to see where your UI breaks because you have super long strings, that's what you can do there. If you want to see it somewhere in San Francisco, you can change the system region here, or you can turn on show non-localized strings, and all the strings that are not localized will be in caps lock. And for environment variables, under diagnostics, you can enable some for malloc scribble or malloc guard edges. Those are environment variables. But for all the other ones, you would have to do them in the arguments tab. So these are the 4 launch arguments that I'm going to talk about. First is the layout feedback loop debugger that I already mentioned. Then I'm going to go over concurrency debug, migration debug, and SQL debug for core data, and then NS-trace events. So the layout feedback loop debugger. As you've seen already, I set a launch argument which defines a threshold. So you can set actually a value between 50 and 1,000. And what it does, it will count the number of views that run layout subviews. And once you hit that threshold, an exception breakpoint is triggered. And it will just dump into some logs. It will dump into logs, basically, which views are responsible for this. And if you don't want to actually go through the logs, you can set an exception breakpoint, and then you can print out the layout feedback loop debugger on underscore UI view layout feedback loop debugger. But I don't want to actually go into details what is printed out there because it's a lot. So I'm going to point you to this talk from WWDC in 2016 and what's new in auto layout. And Marianne Galdin is actually talking 50 minutes about what you can do with this. So this is great for auto layout issues and a very handy argument. But what about other areas? Core data is widely used, but it's not always easy to debug when things go wrong. So this argument here, concurrency debug, will help you to figure out if you're accessing some objects from a context from the wrong dispatch queue, like an object context or a managed object. So when you turn this on, you will see a log that says core data annotation, core data multi-threading assertions enabled. And after that, whenever you access an object from the wrong dispatch queue, you will land in the all that is left to us is honor exception. Fun fact, Apple tried turning that on by default, or not tried, they did, in iOS 6. And a lot of apps actually crashed, so they pretty soon turned that off again. If you want to learn a little bit more about this, Ole Biggemann wrote an article about this. So next up, at some point you probably have to migrate your data from one model to another. For this, there are also two handy launch arguments. The first one is migration debug. This will log information about exceptional cases when you migrate data. It will, for example, print out the hash values of the objects that are being migrated. And the second one is SQL debug. So you might wonder, why is there 3? Normally it's like a 1 and a 0. Well, the 3 determines the level of verbosity. The first one is less information, and the third one is all the information that you can get. And what it does is, it will print all the SQL statements that are happening underneath. So you can actually see what core data is doing under the hood. Super interesting. And something that I found out while I was learning about launch arguments is that you can also pass them at runtime. So in this case, I was passing the NS-trace events to the text editor. And what I did then was I was hovering with the mouse over the text editor, and I could see what mouse events the text editor was getting. So there are lots of these hidden launch arguments and also environment variables, and these are just a few examples. If you want to figure out a little bit more and learn about different other launch arguments, I would highly recommend the iOS Debugging Magic keynote, or tech note, and the macOS Debugging Magic tech note. They're a little bit old, but there's still so much valuable information in it. But there are not only predefined launch arguments, you can also add launch arguments and environment variables yourself. And I think you heard that already by John this morning. You can use them for testing. Here in this case, we're using the skip onboarding one to skip directly to our main screen if we have it set. You can read it out over by using the process info. And you can also use the user defaults for this. And you can do the same thing if you define your own environment variables. Instead of just using the arguments, you can just read out the environment. And if you have a server URL there set, for example, you can just use that one, otherwise the default one. And you can also use that, for example, if you have your own frameworks and you would like to have more logging enabled. So this is great, but sometimes you don't have a specific problem or a bug yet, and sometimes you just try to make things work, right? So let's go over some typical time-consuming tasks and how you can save time. Talking about speeding up debugging. So first up, I would like to show you an easier way how you can inspect private properties without having to subclass. With Swift 4, Apple introduced the KEYPATHS pattern. We can now easily observe changes without having to subclass. Before, I would just go everywhere through my code, and I would create another class. I would overwrite the setter just to see from where it is called. And in this case, I can just add this in my code, and I don't have to go later on everywhere through and just replace my subclass. Next up, the PO UI application shared, where we're not getting, where we get the error message that property shared was not found on the object. And could I see a short raise of hands who has ever encountered that problem? OK, quite a few people. I'm not sure if you know why this is happening, but there are two contexts that we have. One is the Objective-C context, and one is the Swift context, the debugging context. And by default, the Objective-C one is chosen. So you actually need to tell LLDB, hey, the object that I'm giving you is a Swift object. And when I started out with Swift, this was what I was using. So I was telling it expression minus L Swift minus O, your application shared, and then it would know, oh, OK, you've got a Swift object here. But that's obviously tedious to do this with every argument. So next up, what you can do is you can just import UIKit or import Foundation. And that also removes the need to cast structs in a lot of places. But that's also tedious, and always doing that is not fun. So next step up is you just create a breakpoint on your application main. And I want to thank Krzysztof here because he was writing a blog post about this, and that helped me a lot. So what you do is you create that on UI application main, and you add two debugger commands. One is expression import UIKit, and one is expression import Foundation. And then you just check that little check mark at the bottom, which says automatically continue after evaluating actions. Now you don't have to do this ever again. This is already a lot better. But what you can do as well is, if you don't only want to have that in this one project, but in all other projects that you have and future projects, you move this breakpoint into a user breakpoint. And if you want to be nice to your colleagues, you make this a shared breakpoint. So this one, I think, is already super, super handy. So I wondered, are there more? And I stumbled upon the NSKVO deallocate breakpoint. This will break where KVO complains about observers still being in place. So when you deallocate an object, but the observer is still in place, your app crashes when it still gets a message. And this breakpoint will actually warn you beforehand, before you experience the first crash, that you missed removing an observer. And another one that I find pretty handy is you can just edit your exception breakpoint and print out the first argument. And now you wonder, what is the first argument? Well, that's actually the exception that you're getting. So I sometimes had to hit continue over and over again until the exception showed up. But this way, it's immediately printed out. So those were just 3 examples, but there's so many more, and PSPDFKit has written a great blog post about it in 2017. So if you want to check out what more breakpoints you can set up, definitely recommend that article. But breakpoints aren't the only way to speed up your code. I would like to loop back to LLDB, the low-level debugger. And I know it's not the most intuitive tool, but it's a mighty tool. And I'd like to give you some examples. So the first one is changing variables at runtime. So in this case, I'm stopping right after declaring a let. And normally you cannot change this, but when you have LLDB, you can actually change this at runtime. And you can just use e and sum equals 4, and when you then continue the program, it will have that value. But you cannot only do that when you stop at a breakpoint like this. But if you have, for example, your UI view debugger, and you have an address, you can use that to, for example, cast your view and change the frame. We recently had the problem that we had a button that we couldn't hit, and when I looked in the UI view debugger, I saw, oh, the height is 0. Oh, maybe that's the issue, but I wasn't entirely sure. And sometimes it's really hard to get into that problematic state again. So when you actually change that at runtime, you can avoid having to change your code and like recompile and try to get into that state again. So we tried changing the frame and then hit continue, and we saw, OK, now I can hit that button again, and it wasn't something else. So when I learned about this, I was amazed. That was like a whole new world for me. But there's more. Like, you can also extend LLDB by scripting your own scripts, basically, with Python. For that, you use command source. This is an easy script that just printed the thread info and afterwards listed the breakpoints. If you want to learn more about this, there is a blog post by Fabian Guerrera. And one tool that is actually using this extensively is Facebook CHISEL. Facebook CHISEL is a collection of handy LLDB commands, which you can easily install over Brew. And then you just have to edit the LLDB init, which will then load with this command the Python script, where they have to find all of these commands. I'll just show you a couple of examples what you can do with it. So you can use pviews to print the recursive view description for the key window, or you could use visualize when you're like drawing something in a CA layer or in a UI view and you want to just see how does it actually look. Right now it will open that in the preview app. Or you can use pal trace to print the outer layer trace for the given view. So all great tools to speed up debugging. But what about the cases where we know that we entered a bad state? How can we make life easier for us, our future self, or our programmers? Good practices for error handling. So how can we save time here? The first time that comes to mind when you think about error handling is hopefully assertions, and in particular assert and assertion failure. These are runtime checks to catch programmer errors early on. So asserts ensure that certain conditions are met, and if not, the app will terminate early on. So here's an example. We have an optional string, and when it is nil, we assert it and say that's an invalid parameter, because afterwards we would crash because we're force unwrapping that. And as you can see, there's a message, and this actually gives you the chance, if you're writing your own framework, to educate your users how to use your framework and why it is going wrong. And for assertion failure, you would use that in parts of your code that shouldn't be actually hit. In this case, I have a switch case, and when you get into the default case, you might have forgotten to actually handle a new cell type that you've added. Or further down, as the person that was actually coding this, I know when you land down there, not even in the default case, that you probably got somewhere in the other cases above, but the cell was nil, so you probably have forgotten to register the identifier. And this helps the next person that is using your code to not only know what is wrong, but also how they can probably fix the problem. So something that you should know is assertions are only enabled in debug mode. They're not going to be there when you run it in production. So I was wondering, OK, what does actually determine the debug mode? And that is the Swift optimization level. If you have it set to O none, it is the debug one. If you have it set to O, it's release. And there's another one which is O unchecked, and that will give you blazing performance, but it does that by removing a lot of error checks. Like, for example, array out of bounds or unwrapping nil is not there anymore, and in the worst case scenario, that will end up in memory corruption. So please don't do this unless you really know what you're doing. So, but what do you do if you need to guard against the bad state in a release build? Well, for that, we have precondition and fatal error. These are conditions where what would be too dangerous to continue, because it might, for example, corrupt data. And precondition failure and fatal error are even enabled in unchecked releases. So let's look at an example from the Swift library. So the repeated value function lets you create a collection with the same value repeatedly, depending on the count. Setting the count to a negative value would later on crash. So in this case, we exit early here, and in debug, we would get the message repetition count should be non-negative. Next, an example for fatal error. This is in the NSDate formatter class, which uses the ICU-C library. And as you can see in the guard block, We cannot talk to the International Components for Unicode library. That's what ICU stands for. And that is an unrecoverable system state. So in the crash log, it will actually appear that we couldn't talk to it, and the app is terminated. And what I found out, apparently some developers are using fatal error whenever they detect that they're being run on a jailbroken device. So that way they can avoid that people cheat in their games. So just a little recap, what functions are available and what. So in the debug mode, all of these work. In release, for assert and assertion failure, we just continue. Oh, by the way, you can also call functions in assert and assertion failure if you want to for some checks. In the unchecked release, we only have precondition failure and fatal error. So yeah, we learned how we can get more information by using read register and using some launch arguments. We saw how we can speed up debugging and making our code work by using KEYPATHS, user breakpoints, LLDB, and CHISEL. And we learned how we can use assert, precondition, and fatal error to educate our future selves and our fellow developers. And these are my resources, and that was it. Thank you.